Hello guys, my name is Nikolai Yusupov. In this video I would like to show you how to assemble a ventilator circuit and essentially set up the vent for your CC medic, right? So this video is essentially for the EMTs who are working with a critical care medic. So here, what I have here is the LTV-1200 ventilator, right? I have the high pressure hose, I have the oxygen, and very important that your regulator has the high pressure, right, connection. What else you're going to need for your circuit connection? You're going to need adult or pediatric vent tubing. So here I have an adult tubing with all the accessories inside, right? I have the HEPA filter, so this doesn't allow pathogens and bacteria to go into the ventilator. And here I have capnography, which is going to be connected at the end piece and then plugged into the cardiac monitor. I'll show you how this looks once we actually do it and explain all this. So the first thing you're going to do is when you're setting up a ventilator and you grab it out of the ambulance, very important, you want to look at the high pressure hose, this part right here. I often find them loose, right? So you see, right, it's loose here. If this is loose, you are going to be bleeding oxygen, so you'll come up with, let's say, a full tank of oxygen in portable, and if this is loose, it will just leak out. So make sure all your connections are tight. So this is tight, right? So once this is tight, I make sure, right, and you want to also make sure that you select the tank that's not empty. So I look at my gauge, right, this is 1500, right? Take the tank that has oxygen, because depending on how much percentage they're getting, it may take quite a lot of oxygen, so you don't want to come up with like 1,000 or less, right? So the next thing I do is I connect my hose. I'll show you how it's going to be situated in the back of the stretcher, but for now I want to show you how I connect everything. So step one, right, we make sure that this is tight, right? Step two, I take this, and this is going to connect right here. So you want to make sure this connection is very tight, and right, so this connection is tight. For now I'm going to lay it here so you guys can see everything, how it's done. So now my connections are solid. The next thing I'm going to do is I'm going to open the ventilator circuit, and I'll show you all the components that you're going to need, right? So when you open the ventilator, right, you have the accessories and the major ventilator circuit. So this is the ventilator circuit that you're going to be connecting to, and I'll explain all the sense lines, right? This is an accessory tubing that you can employ if you want to, let's say, run a nebulizer or some other things, right? We do not need it right now, right? So this is the major vent tubing, and then you will have some accessories in here, right? The two I'm holding, right? This one is when you place this on the endotracheal tube or tracheostomy, right, on the patient, and it's able to adjust, so you easily able to manipulate the Y. The Y is this portion of the tubing, right here, right? So this is the Y, and it will allow you to, right, to move it easily. This portion is very important. This is the adapter, right? I'll show you on this diagram. You do not want to lose this, right? So this piece that I'm showing you right now, this is called the 22mm connector, right? This is this piece, and on this piece is where you're going to connect your HEPA filter. If you're missing this connector, you will not be able to connect the circuit properly, and you will have an air leak, right? So this is the 22mm connector. I'll show you how it goes. So on the side of the ventilator right here, right, you will see the 22mm connector is going to be connecting like this. Sometimes when you take the ventilator out of the ambulance, this may already be here. If it's already here, just leave it, right? But if it's not here, that's what we're placing onto first, right? So we got the 22mm connector. The next step that you're going to connect is you're going to take this HEPA filter, right? And very, very important, right? When you guys connecting this, I've seen some EMTs connect this here. This will create high pressure for the patient when you're connecting it. So this should never go on this Y port towards the patient. So if this is going to the patient, it should never be here. The HEPA filter is always connected to the 22mm, right? And when you're connecting your circuit, make sure everything is tight. So now we got the HEPA filter, right? Once the HEPA filter is on, I will explain to you the different parts of the circuit and how to connect it better, right? So if you notice, right, we have essentially two limbs. We call it two limbs of the circuit. The longer limb, right, this is the inspiratory limb. This is where the patient is getting gas and oxygen. So this is called the inspiratory limb. This is how the patient is getting oxygen. This one right here is called the expiratory limb. this is how a patient exhales oxygen. So you want to pay attention that this part, the one that's in red, is not covered with like sheets, blankets, right, or anything else, right? And very important, you don't want any kinks in the tubing. So the long tubing is the inspiratory limb. This is the piece that's going to go into the ventilator. This is how the patient is getting oxygen. This piece is the expiratory limb, how patient is exhaling, right? And these pieces here, right? The one at the top, we call it the high pressure, right? Readout. So essentially, it gives you the high pressure limit. This is going to be the low pressure limit at the bottom, right? These are the sense lines. And over here on the expiratory limb, you see there's one more, right? There's one more, and that measures the patient exhalation, right? So it's very, very important that we get these readouts and these sense lines are connected properly. And I'll explain. So it's very, very important that when you're connecting this to the patient, right, to the trach tube, right? When you're connecting this or to the ET tube, that these sense lines are upright. They're never pointing towards the bottom. If these sense lines are pointing towards the bottom, you may get condensation, and you will have this sense alarm. So you'll have erroneous readouts if water or condensation, right, gets into these. So you want it to be upright, so nothing is filling them up. So now how we are connecting it. So I'm going to come to the ventilator. I'm put to the side so you can see. Are you able to get it, right? So this, we said this is the inspiratory limb. This is going to be sitting right here. Right, this is how the patient is getting oxygen, right, to them. So make sure this connection is tight, no kinks, right? So once this is done, the next step, I'm going to show you how to connect sense lines. I'm going to open this up so you guys can see it clearly, right? So here is where the sense lines are going to go. So I'm going to come over here, right? And I'm going to connect them. And just to show you on the diagram, right, so you guys can see it, right? So we have the sense lines, the one at the very top, right? At the very top, we call it the high pressure sense line, right? High pressure. The one at the bottom is low pressure. How you remember, right? It's at the top, so it's high, so it's high pressure. The one at the bottom is low pressure. I also, when I check my circuit, I always want to make sure they are in fact engaged, right? They're not loose over here, right? So this is in fact engaged. Sometimes from the factory, it might be loose, and also want to make sure my circuit here is engaged, right? So once I got that down, right, how are you going to connect them? So they're usually color coded, right? So white to white, yellow to yellow, and this one, right, there's no hub on it, so it will be the last one. This is the exhalation, right? So the white one, right, this will be high pressure, yellow one will be low pressure, and this will be exhalation. So what I usually do, I come and put this up here so you guys can focus. So I take my high pressure, I twist it in the opposite or counterclockwise direction, and then when I engage it, it will automatically screw in place, and then just make sure it's tight, right? I don't want to have any sense lines that are loose. Same thing for the low pressure, right? It's yellow. So you guys can see it well. Twist it the other way, counterclockwise. Pull this in, it will automatically go inside. And then the last one, the exhalation, right? It will just snap in. So now I have all my sense lines firmly connected, right? And everything is ready to go. Now, so this is how it looks. Now, the next thing I'm going to show you is something called end-tidal CO2 capnography. And whenever we're doing transport with patients that have endotracheal tube or tracheostomy tube, we must monitor how much carbon dioxide they're making. It's a requirement by REMAC, right? And anytime you are doing these transports, this must be connected. However, right, when you connect it to the circuit, right, it is going to be connecting to our monitor. Don't connect it to the monitor just yet. I'll show you why. So this is the adapter, right, with the orange plug that you need, that's going to be measuring our carbon dioxide, how much we exhale. And it's usually plugs into the monitor right here, right, where it says CO2, carbon dioxide, right? So first I'm going to show you where it goes. So usually when we connect this will be the very end piece right here, right? And then this piece will be like so, right? So this is going to go to the patient's endotracheal tube or tracheostomy tube. In between this was our capnography, right? And where does this plug in? This plugs in into the monitor right here. But notice, if I plug this in, right, into the monitor, and the patient is not connected, it's going to tell me there's apnea, because it's sensing that nobody's breathing, right? So once it's connected, you see respiratory rate, right? And is nobody's breathing. So if I pull up my waveform for carbon dioxide, right, CO2, you're not going to see anything, right? And it will alarm. Why it will alarm? It will alarm because it's sensing apnea. Apnea means there's no breathing. It's detecting no breaths. So I would wait to connect this to the monitor, and when the medic tells you to do so, right? You could connect it to the circuit, but just don't plug the orange piece into the monitor. When the patient is breathing, I'm gonna take this piece out. I'll show you how it looks. When the patient is breathing, I'm gonna breathe into it. So you see, right? It tells me my end-tidal CO2 is 38 and my respiratory rate is 26, right? So when it's detecting carbon dioxide in the sensor, it will start registering a waveform. But until it does it, it will not register and will alarm, right? Apnea. So what I'm telling you to do is, do not connect it just yet to the monitor, right? Do not connect it here. What you're gonna do is you're gonna connect this piece to the circuit and this very end piece here, right? As I said, right, when you are connecting to the patient, make sure the circuit is upright and these sense lines are upright. I'll show you what I mean on this graph. See if I can put it here, which I'll take it now, sure. Right, so what we discussed, right? So this part is the Y, right? It's this part here. It's going to go towards the patient. You want to make sure the Y, the sense lines connections are oriented upright, right? So there's no condensation. We talked about, right, the inspiratory limb with the 22 millimeter connector. That's this piece right here. We talk about the expiratory limb, right? That's the other connector that goes here, right? And then what's important for you to know, right? We said that the exhalation valve, the red piece, right, that one, do not cover it with sheets. Because it will be hard time for the patient to exhale. So now, the reason why I tell you to keep this upright is we have these alarms, right? So alarms is not just something making sound, right? We see the priority level is high. So we look at this alarm that's called this sense, and it usually means a disconnect, and it's high priority. So what it usually means is you may have circuit disconnect. So any of these pieces, right, this could be disconnected, or these could be disconnected, or they could be kinked, right? So if they're kinked or disconnected, it's not just an alarm, it's the ventilator stops giving the patient's breath and will go into exhalation. That's why it's very important to connect them tight so they will not come out during transport. And the other thing that you know, it's very, very important to know, right? So this is the alarm, this sense alarm. So when it sends a pinch or a blocked tube, when the sense line has become disconnected, right? And then when the sense line is occluded, excessive condensation. So not too many people know about this, right? I had a patient, I was doing transfer, and I was getting this sense, and what happened is they had this heat moisture exchanger, and some liquid basically went into these lines, and during the entire transport I'm seeing this sense, and I'm checking my connections, right, and everything is tight. You know, I triple checked everything, and the problem is this, is that I cannot see the readouts, right? It cannot detect, right, it cannot detect the circuit pressure because its condensation is impeding it. And the problem with that is I would have to change the entire circuit during transport, so I would have to take a entire fresh tubing, reconnect everything, right, and then reconnect it to the patient. And ideally, if I was gonna do that, somebody has to bag the patient with a BVM, and if somebody's bagging the patients with a BVM, right, it means my partner has to pull over and come to the back, right? So be cognizant of this, right? And so make sure these are pointing upright, right? So this sense alarms usually look for a disconnect, and then if this is up, you know, pointing down, and water or moisture gets in, right, it will basically not give you good readouts, and again, it will stop. It will say inspiration is immediately terminated, so stops giving oxygen and exhalation begins. So patient goes into exhalation, and this is the alarm that you're going to get. Something else I want to show you, right, when you guys at the patient's bedside, always hold this camera, always take the BVM. So when you're going to be at the patient's bedside, you're going to see the BVM that's connected to the wall, right? It's usually hanging like this, right? And what I always do, I don't want to open this bag, but what I usually do, right, I will take this BVM, I will open this up. Do not throw away the mask. What I usually do, this tubing that goes to your oxygen, I will run through the mask, right? So it's connected, and then the very end of this tubing, right, that's connected to the BVM, right, that's usually connecting to your oxygen, this tubing here that I'm touching is going to be connected to this port right here. So you always want to have a backup device in case your ventilator stops working. All right, you have a BVM, and I usually try to take it from the patient, right, that's hanging behind them, right, or maybe they already connected it to the oxygen. So take this, right, that's essentially going to be one of your tasks, right. Take this oxygen hose, run the masks through it, and connect it. Why do I take the mask? Because sometimes patients may pull the tube out during transport, and now you have, if you have no tube, and it's hard to intubate them, so obviously you can't just, you know, bag them through this port here, right? You have to use the mask, and if you forgot the mask in the hospital, right, then I have to open a new fresh BVM, reconnect everything. So it's just it's longer time, right? The patients that had this sense, I already had the BVM connected. We ventilated the patients, and I was able to change the circuits, right? So essentially, I will show you how I position this, but you want to work with your medic, right? And see what they like. I'll show you how I position my ventilator and my rationale for this, right, when I'm doing this. So what I'm going to do is I'm going to move this guy here for a second, make sure everything is tight. So I'm just reconnecting everything. So this will be in the back of the stretcher. I'm going to move it to the side for now. So how do I position this? Right, move the sheets. So the first thing that I usually place at the bottom is my oxygen. And the reason I place it like this is that when I get here, right, I can easily disconnect my high pressure and connect it to my main tank, right? So this is how the O2 is usually stays, right? And my ventilator is going to be laid on top of it like this. So I'll tell you the rationale for that, right? So the reason why I place this like so is that when the ventilator is on, let's select same patient. I put a glove on this just to simulate like the patient is getting oxygen. So the reason why I'm positioning it like so that when I'm sitting and I'm providing patient care, I can see all my alarms and all my readouts. So I'm constantly listening, right, when it beeps, and I'm looking why it's beeping, like what's going on, right? Again, the high pressure hose is here, so I could disconnect and easily mount it to my main tank, right? And ideally, right, when you come to your shifting on the 800 the bus, make sure you know how much is the main, right? Whenever you're doing these critical care transports, patients may be on 100% oxygen, so right, it's very important to check, right, that you are, you know, fully stocked. This, right, as we said, right, this will be usually I run it around, right, so I'll show you how it will be. So if a patient was on my stretcher, I usually have the head of the bed about 30 degrees, right? And then this will be in my monitor. Usually I have the securing device for my monitor on the legs, right? The defibrillator platform, or we call it, you know, the pack, right? So it'll be at the feet. The monitor will be on top of it. This will be connected here, right? This is essentially running, right, to the patient, and patient is getting right, the oxygen this way, make sure the Y is connected upright, right? So, and you don't want to have any kinks, right, in the lines. Sometimes you may go from this side or the other side, doesn't really matter, as long as these sense lines are upright. And always make sure no kinks, right, and nothing is occluding my sense lines, right? And this is how I would perform, you know, the transport. Ideally, right, when you get the CC call, right, this is your setup, right? You set this up, talk to your medic, right? And this is, you know, if I am setting up, let's say, drips, or I'm getting a report, and I come to the stretcher and I see all this, right? You already connected everything, right? I'm happy, because now I already know, right, this is all set to go. All I have to do is input my ventilator settings, and I'm ready to go. So this will be the setup for the EMT who's working with the critical care medic.